So we have two blocks in the figure and they're both sliding down an incline. We want to figure out what the tension is in the string, in the massless string. And we have, as our knowns, mass of block 1 is 1 kilogram. That's its friction coefficient. The angle of the incline is 20 degrees. Mass of block 2 is 2 kilograms. Friction coefficient 0.1. We know that it's accelerating down this incline in the positive direction. Here are our FBDs. So our gravitational force will be at an angle, which we will have to define in both the vertical and horizontal direction. And what's interesting about this one, block 2, is that the tension force is pointing in the opposite direction. So these two will cancel each other out and equal 0, which we'll see in the force diagram. We also know that tension in the string, so we know that tension in the string will be the same for the blocks, both of the blocks. That's why they cancel each other out. And if the blocks move together as one unit, their acceleration will also be the same, which we'll see later, I guess. So this is our force diagram we're going to fill out. So Fn for block 1 in the x direction is 0, and it'll just be Fn for the vertical direction, and we'll redefine that as the opposite of our gravitational force, which will be mass times gravity times cosine theta. And then block 2, a similar thing is going on, you can see. And then for Fg, we define that as Fg sine theta for the x direction, negative Fg cosine theta for y, and kind of repeat for block 2. But I think one of the things that's tricky is keeping track of your subscripts. So you'll notice that all the masses are different. So this is my mass 1, mass 2, which can be difficult to keep track of. Then for friction, we have, since it's in the negative direction, it's the negative coefficient, the first coefficient of friction times what normal force will be, and we'll redefine that as the coefficient times the mass times gravity times cosine theta, which we determined was the opposite of our gravitational force. And we do the same thing for the other one. Y direction is obviously 0, and then down to the tension force, which would be positive. This is in the positive direction, and for our block 2, it's actually going to be pointing the opposite direction, so it will be negative, which is important to know. And then y direction will obviously be, or the vertical direction will obviously be net 0 for both, and because our blocks are accelerating in our positive x direction, it will be positive mass times acceleration. And we'll get our first equation over here to be mass times acceleration and mass times gravity sine theta plus t minus the coefficient times the normal force, which we all get in this column right here. Right? And then we solve for acceleration, and if you plug in all of our knowns that we have in here, over here, and gravity obviously is 9.8, you should, and solve for acceleration, you should be able to get acceleration to equal 1.51 plus t, which we will use later. We'll substitute it into our second equation. And our second equation is this. So be mass times acceleration equals mass times gravity sine theta minus the coefficient times mass times gravity cosine theta minus t. And we get this from our block 2 x direction right here. And we'll get down into a form like this, and here you can see that I substituted our acceleration, or we defined acceleration, into the equation. And if you plug in all of our knowns in correctly, and the tension should equal 0.61, or about approximately newtons. So for the assessment, we know that if block 1 were accelerating faster than block 2, there would be no tension in the string at all. So we know there has to be some tension because of block 2's smaller friction coefficient. Because it has the smaller friction coefficient, it has a greater rate of acceleration, and this difference in acceleration causes the tension. And because both blocks are moving in the positive direction, it seems plausible that this tension in the string would be fairly small, since block 1 is only slightly pulling against block 2.